Today we're on the Central Coast. We're at Grover Beach Elementary, home of the Golden Gophers, and we're here to
Do the math!
All right, once again, we are with some students at Grover Beach Elementary. We've had a lot of bit of fun with the polydrons and making things out of those three-dimensional shapes. Moving on to another activity right now, we're going to look at a word problem. And there are a lot of different ways to solve word problems. Do you guys have any strategies? Like when you see a word problem, things like strategies like, oh, this is how I can do it?
I put it into numbers.
Okay, so you take the words and put them into numbers, right? Make it a little bit easier. What else can you do?
Reread.
Reread it, because sometimes you miss a word or you maybe misinterpret something that they're asking for. What else?
If you don't understand it totally, then you could circle it or highlight it.
Circle words, highlight.
Written information.
There you go. So you want to look for important information, maybe turn things into other numbers, figure out what operation you're going to have to do, right? What is the outcome that they want out of this thing, right? So you kind of figure that out as you're going through it. So here's a problem that I have for you right now. We have 24 feet of fencing. Right? You guys know if you wanted, like if you had a little garden or something, or at your house, you have fencing that goes around it, right? Okay? So if we have 24 feet of fencing, and I wanted to use that fencing, and I wanted to use all 24 feet, how could I arrange it to use all 24 feet?
There are multiple ways. You could have a cube and there are 4 sides, each are 6 feet.
Okay, so I could go like this, right? Where I've got 6 feet here and 6 feet here. And if I come all the way around, will that make 24 feet going around?
Yes.
Yes. Now, is that the only way I could do it? What else could we do?
Another way is that instead of it being 4 sides, if it was connected to the house, it would be 3 sides, and 24 divided by 3 is 8, so it'll be 8 feet.
So I could go like this, where each side is 8 feet, and we have a house here, so you're not using any fencing, but it has a barrier. Is that what you're saying?
Yeah.
So that way we went a little further out, okay? Any other ways we could use 24 feet of fencing to enclose something?
You could have it like an octagon, but 24 sides instead of 8.
So you could go 1 foot each side, right?
Yeah.
That'd be a lot of work, huh? I'm not going to draw 24 1-foot sections, though, all right? So think about this. Think about the factors of 24. Do you guys know what factors are? Mm-hmm. What are some factors of 24?
1.
1, obviously, right? And 1 goes with what? 1 times what?
24.
24. So let's put 24 out here. All right. What else?
6 and 4.
6 and 4. So let's put 4 here, and we'll put 6 here.
3 and 8.
3 and 8. All right. So let's put 3 right there, and we'll put 8 right here.
2 and 12.
2 and 12. They fit nicely right in there. Any other factors of 24 besides the ones we've got? Because we've got a lot. So we've got 1, 2, 3, 4, 6, 8, 12, and 24. Here's one way you can check. We know that 1 and 24 go together. 2 times 12, 3 times 8, and 4 times 6. Now the 4 and 6 are right next to each other, right? Will 5 go into 24 evenly? No. So we know we're through. Those are all the factors. All right? So you could say, all right, I want a 12 by 2. But is that going to work for 24 feet of fencing? No, because that would give us how many? How much fencing would I need?
28.
28. So you can't just use those factors, but they give you a start on how to do this. Instead of doing 12 by 2, what could I change to do this?
10 by 2.
10 by 2. Right? Now that makes 24 feet of fencing. So we've gone over a little bit of the factors, some dimensions that we could use with 24 feet of fencing. When we come back with the students at Grover Beach Elementary, we'll put forth the task to see who can get the greatest area.